Every moon in the solar system is tiny compared to its planet. Jupiter's largest moon is less than 1/27th of Jupiter's diameter. Saturn's biggest satellite is barely 1/23rd of its width. Even our own moon, which we consider enormous, measures just 1/4 the size of Earth. Then there is Charon. Charon is half the diameter of Pluto. It is so massive that the point they orbit around does not even exist inside Pluto. It floats in empty space between them, roughly 960 kilometers above Pluto's surface. No other major system in the solar system works like this. Pluto does not have a moon the way other worlds do. It has a gravitational partner that changes what Pluto itself even is. If you enjoy having your understanding of the solar system completely rearranged, take a second to hit that like button and subscribe. It genuinely helps this channel keep making these deep dives for you. Let's begin. That pattern, every moon dwarfed by its planet, is not a loose trend. It is not a soft guideline with a few messy exceptions. It is one of the hardest, most consistent structural patterns in all of planetary science. Across hundreds of known moons orbiting 8 major planets, the relationship between a world and its largest satellite follows the same fundamental architecture. The planet dominates. The moon is minor. The parent body commands the gravitational stage with absolute authority, and the satellite plays a supporting role so subordinate that the planet barely registers its presence. This pattern holds from the broiling inner solar system all the way out to the frozen reaches beyond Neptune. It holds for rocky worlds and gas giants alike. It holds so firmly and so universally that for centuries, no one had any reason to suspect it could ever break. Then we found Charon, but before we get there, you need to feel how consistent this pattern really is. You need to see how reliably every other system in the solar system obeys it, because only then does the violation at Pluto land with its full weight. Start with Jupiter, the largest planet in our solar system. A world so massive it contains more matter than all the other planets combined. Jupiter stretches approximately 139,800 kilometers across. Its largest moon, Ganymede, is the single biggest satellite orbiting any planet in our cosmic neighborhood. Ganymede measures roughly 5,268 kilometers in diameter. It is larger than the planet Mercury. It has its own internally generated magnetic field, a layered interior of rock and ice, and a subsurface ocean that may contain more liquid water than all of Earth's oceans put together. If Ganymede orbited the Sun instead of Jupiter, we would call it a planet without hesitation. But place Ganymede next to Jupiter, and it disappears. The diameter ratio is the part you can picture, 1:27. The mass ratio is the part that breaks intuition. Ganymede is approximately 1/12,800th of Jupiter's mass. If you stacked Ganymede on one side of a cosmic scale and Jupiter on the other, you would need nearly 13,000 copies of Ganymede to balance the planet. Jupiter does not wobble because of Ganymede. It does not sway or shift or respond in any measurable way to its largest moon's gravitational pull. The influence flows in one direction only, from planet to moon, and Ganymede follows along like a leaf caught in a river current, tracing its orbit obediently, while the river does not even notice the leaf is there. Saturn tells the same story with different scenery. The ringed giant spans approximately 116,000 kilometers in diameter. Its largest moon, Titan, stretches roughly 5,150 kilometers across. Titan is one of the most extraordinary places in the solar system. It possesses a dense atmosphere of nitrogen and methane, thicker at the surface than Earth's own atmosphere, with lakes of liquid hydrocarbons and weather systems that make it arguably the most Earth-like world orbiting any other planet. And yet, relative to Saturn, Titan barely registers. The diameter ratio is approximately 1:23. The mass ratio drops to roughly 1/4000th. Saturn could swallow more than 4,000 Titans and still have room left over. The gravitational relationship between the two is entirely one-sided. Titan orbits. Saturn presides. There is no ambiguity about which body controls the system. Move farther outward to the ice giants, and the pattern holds without flinching. Uranus has 27 known moons, the largest of which is Titania. It measures approximately 1,578 kilometers in diameter. orbiting a planet roughly 50,724 kilometers across. That gives a diameter ratio of less than 1 to 32. Titania has icy canyons and ancient crater terrain, but compared to Uranus, it is cosmically insignificant. Neptune possesses Triton, a world with active geysers of nitrogen gas erupting from its frozen surface. Triton is genuinely large, roughly 2,707 kilometers in diameter, larger even than Pluto, but set against Neptune's approximately 49,528 kilometer girth, Triton comes in at about 1 to 18. Still a small fraction, still unambiguously subordinate. The planet dominates, the moon obeys, the hierarchy remains intact. And this pattern is not just visually consistent, it is gravitationally consistent. When a moon is 1/4000th or 1/12,000th of its planet's mass, it has essentially zero influence on the planet's behavior. The planet does not move in response to the moon. It sits at the gravitational center of the system, and the moon traces a neat path around it. The center of mass of the pair, the barycenter, sits so deep inside the planet that it is virtually indistinguishable from the planet's core. For Jupiter and Ganymede, the barycenter lies comfortably inside Jupiter. For Saturn and Titan, it sits deep within Saturn. For Uranus and Titania, for Neptune and Triton the same. In every case, the barycenter is buried beneath the planet's surface, invisible and irrelevant to the system's visual appearance. The planet holds the center. The moon circles the outside. That is how moons work. Then there is Earth and the moon. This is the one pairing in the solar system that has always given astronomers a reason to pause. Our moon measures approximately 3,474 kilometers in diameter, orbiting a planet approximately 12,742 kilometers wide. The diameter ratio is roughly 1 to 3.7, about 1/4. Among all the major planets, this is the closest any moon comes to rivaling its parent body in size. Astronomy textbooks flag the Earth-Moon system as unusual. Lecturers call it an outlier. Some planetary scientists, usually with a slight smile, have even described the pair as an almost double planet, and the moon's size has real consequences. It is massive enough to raise tides in Earth's oceans, pulling water into bulges that travel around the globe roughly twice per day. Its gravitational influence stabilizes Earth's axial tilt, preventing the dramatic wobbles that could otherwise trigger extreme climate swings over geological time. It has gradually slowed Earth's rotation through tidal friction over billions of years. This is not a decorative companion. The moon matters. But even our moon, the most proportionally massive satellite among the major planets, is still clearly the junior partner. The moon is 1/81st of Earth's mass. The barycenter of the Earth-Moon system sits about 1,700 kilometers below Earth's surface, deep inside the planet, offset from the core but firmly underground. Earth does not orbit the moon. Earth does not visibly respond to the moon's pull in any way you could detect by watching from space. The system is lopsided enough that the classification is never seriously in question. Moon orbits planet. The gravitational hierarchy is clear, so the pattern is universal. Among the gas and ice giants, the largest moon is between 1/18th and 1/32nd of the planet's diameter. Among the terrestrial planets, even the most extreme case, Earth and the Moon, still shows a 4-to-1 diameter advantage and an 81-to-1 mass advantage for the planet. Every system, without exception, features a dominant central body and a clearly subordinate satellite. The planet holds the center. The Moon circles the outside. That is how the solar system works. That is how every textbook, every simulation, every model trained us to expect moons to behave. Now travel outward from everything you know. Past Mars and its 2 tiny moons, Phobos and Deimos, neither one larger than a small city, so small they look more like battered potatoes than worlds. Past Jupiter and its sprawling court of nearly 100 known satellites. Past Saturn with its rings and its own crowded family of moons. Past the ice giants and their frozen companions. Keep going. The sun fades behind you. Sunlight weakens to a dim glow, then a faint glimmer, then something barely distinguishable from starlight. Temperatures drop toward -230 degrees Celsius. You are entering the Kuiper Belt, a vast reservoir of icy debris left over from the formation of the solar system, extending from roughly Neptune's orbit outward for billions of kilometers. It is cold. It is dark. It is about as far from the warmth and familiarity of the inner solar system as you can get while still remaining gravitationally bound to our sun. Out here, at an average distance of approximately 5.9 billion kilometers from the sun, drifting through the permanent twilight of the outer solar system, where noon looks like deep dusk, sits Pluto. A small world of nitrogen ice and frozen methane, roughly 2,374 kilometers across, smaller than Earth's moon, smaller than 7 other moons in the solar system. Pluto is tiny. By every measure, it is a modest world in a lonely corner of space. And orbiting this tiny world is something that should not exist if everything the inner solar system taught us about moons is true. Charon measures approximately 1,212 kilometers in diameter. Pluto measures approximately 2,374 kilometers. The diameter ratio is approximately 1 to 1.96, essentially 1 to 2. Charon is half the width of Pluto. Let that land. Half. Not 1/27th, like Ganymede relative to Jupiter. Not 1/23rd, like Titan relative to Saturn. Not even 1/4, like the Moon relative to Earth. Charon is half the diameter of the body it orbits. If you placed a photograph of the two objects side by side with no labels and no context, you would not instinctively identify one as the planet and the other as the Moon. You would see two objects of comparable size, and you would assume they were partners, companions, siblings. You would assume they belonged together, not that one owned the other. The mass ratio is equally extraordinary. Charon is approximately 1/8 of Pluto's mass. 1/8. To absorb how extreme this is, line it up against every other moon-to-planet mass ratio in the solar system. Ganymede to Jupiter is 1 to 12,800. Titan to Saturn is 1 to 4,200. Triton to Neptune is roughly 1 to 4,800. Our moon to Earth is 1 to 81. And then Charon to Pluto arrives at 1 to 8. The jump from 1 to 81 to 1 to 8 is not a gentle step along a continuum. It is a cliff. Charon does not sit slightly above the other moons on some smooth curve of proportional size. It occupies a completely different regime, a different category, a different kind of gravitational relationship entirely. To feel this difference in your bones, imagine what it is like to stand on the surface of these worlds and look up at their largest moons. Stand on the cloud tops of Jupiter and search for Ganymede. Even at its closest, Ganymede would appear as a modest disk in the sky, roughly half the apparent width of the full moon as seen from Earth. Visible, yes. Recognizable as a sphere, certainly, but small enough to cover with the tip of your thumb at arm's length, and still clearly the minor partner in a system dominated by the giant beneath your feet. Now stand on Earth and look up at our moon. The familiar silver disk spans about half a degree of arc. The moon feels large because of its cultural significance, because it has shaped human calendars and poetry and navigation for millennia, but physically it covers a tiny patch of sky. Now stand on Pluto's surface, on the frozen nitrogen plains, and look up at Charon. What you see is not a dot. It is not a disk the width of a fingertip. Charon would span approximately 3.8 degrees across Pluto's sky, nearly 8 times the apparent width of the full moon as seen from Earth. It would hang there, vast, a grey sphere dominating one section of the sky above mountains of water ice capped with methane frost, and it would never move, not a centimetre, not across hours or days or centuries. Charon would remain frozen in exactly the same position in Pluto's sky, permanently fixed, a motionless world hovering above the horizon like an object painted onto the ceiling of reality. From one hemisphere of Pluto, Charon is an eternal presence overhead. From the opposite hemisphere, it is forever hidden below the horizon. You could spend your entire existence on that far side, and never have the faintest suspicion that Charon existed at all. No other moon in the solar system creates this experience. No other satellite looms so large in its planet's sky, while simultaneously remaining perfectly, eerily stationary. The visual relationship between Pluto and Charon is without precedent among any known pair orbiting any known world. And that visual relationship is not just an aesthetic curiosity. It reflects a gravitational reality that runs much deeper than appearances. In every other planetary system, the Moon is so small relative to the planet that you could remove it entirely, and the planet's behavior would barely change. Even removing our Moon from Earth would alter tides and axial stability over geological time. But Earth itself would keep orbiting the Sun on virtually the same path. Those moons decorate their planets but do not define them. The planet's identity exists independently of its satellites. Charon presents the opposite situation. Remove Charon from the Pluto system, and Pluto's orbital behavior changes measurably. Its rotation rate, its orientation in space, the gravitational environment experienced by its 4 tiny outer moons, all of these shift when Charon is taken out of the picture. Charon is not a secondary feature. It is structurally woven into what the Pluto system even is. That distinction between a moon that decorates a planet and a moon that defines a system is the reason Charon breaks every rule the rest of the solar system established. The discovery of this extraordinary companion happened almost by accident. In June of 1978, astronomer James Christie was working at the United States Naval Observatory Flagstaff Station in Arizona. He was not hunting for moons. He was doing the careful, unglamorous work of measuring Pluto's position against background stars to refine calculations of its orbit. Pluto had been known since 1930, when Clyde Tombaugh discovered it after a painstaking photographic search. For nearly 5 decades, it had been treated as a solitary object, a lonely outpost at the edge of the known solar system. Nobody expected it to have companions. But when Christie examined the photographic plates, something looked wrong. Pluto's image was elongated, slightly stretched in one direction, as if someone had gently smeared the exposure during processing. The distortion was subtle, just a small bulge on one side of what should have been a round dot of light. Most astronomers might have dismissed it as a flaw in the plate or an artifact of atmospheric turbulence. Imperfect tracking of the telescope could produce smeared images. So could temperature variations in the atmosphere between the telescope and the stars. Christie checked. He examined the background stars on the same photographic plate, stars that sat at similar positions and would have been affected by the same atmospheric and instrumental conditions. They were perfectly round, crisp, symmetric pinpoints of light with no elongation at all. Whatever was stretching Pluto's image was not a problem with the telescope or the air. The distortion was real. Something was physically present near Pluto, close enough and bright enough to pull its photographic profile out of shape, blending its light with Pluto's in a way that made the combined image look elongated rather than round. Christie dug into the observatory's archives and pulled photographic plates of Pluto from previous years. The same elongation appeared again and again, observation after observation, stretching back through earlier data. And it moved. The bulge shifted position around Pluto with a regular, repeating period that matched approximately 6.4 days. It circled the dwarf planet like a clock hand sweeping a tiny face, visible even from billions of kilometers away. Because whatever was orbiting out there was not a small captured rock. It was something large enough to measurably distort Pluto's image on photographic film across nearly 5 billion kilometers of empty space. There was only one explanation that fit. Pluto had a moon, and that moon was enormous. Christie named it Charon, after the mythological ferryman of the dead, in Greek mythology, who carried souls across the river Styx to the underworld ruled by Hades. The connection to Pluto, the Roman name for the god of the underworld, was a deliberate echo. But Christie had a second, quieter motivation that he freely admitted. The first 4 letters of Charon, C-H-A-R, matched the nickname of his wife, Charlene, who went by Char. It was a personal tribute embedded in a scientific name, a human gesture woven into a discovery that would reverberate through planetary science for decades to come. The announcement was met with skepticism. Pluto was so distant that claiming to resolve a companion from ground-based photographs seemed reckless. But within months, independent observations confirmed that the bump was real. The 9th planet, as it was still called at the time, had been hiding a secret since its discovery in 1930. For 48 years, every photograph of Pluto had unknowingly included Charon's light blended in with it. We had been looking at two objects and calling them one. What followed was a slow, methodical process of confirmation, and with each step the astonishment grew. Early measurements of Charon's size and mass were crude, limited by the technology available in the late 1970s and 1980s. From Earth's distance, Pluto and Charon were so close together and so faint that even the best ground-based telescopes could barely separate them into two distinct points of light. The initial estimates carried large uncertainties, but even those rough numbers told an extraordinary story. Charon was not a tiny captured asteroid. It was not a fragment of debris. It was a world, and it was shockingly large compared to Pluto. A stroke of extraordinary geometric luck provided the critical breakthrough. Between 1985 and 1990, the orbital plane of Charon happened to align edge-on with Earth's line of sight. This meant the two bodies repeatedly passed in front of each other as seen from our vantage point, creating a series of mutual eclipses and transits. These mutual events, as astronomers called them, were scientifically priceless. When Charon crossed in front of Pluto, the total light from the system dropped by a measurable amount. When Pluto blocked Charon, the dip was different. By carefully timing these brightness changes and measuring their depth and duration, scientists could extract precise information about the diameters, surface reflectivities, and orbital characteristics of both bodies without ever needing to resolve them into separate images. The mutual events would not repeat for another 124 years. Astronomers seized the window with everything they had, coordinating observations from telescopes around the world. The data poured in over 5 years of eclipses, each transit refining the picture further. The results confirmed the photographic hints and then exceeded them. Charon's diameter locked in near 1,212 kilometers against Pluto's 2,374. The mass ratio settled at approximately 1:8, later refined through Hubble Space Telescope observations and ultimately confirmed by the New Horizons spacecraft during its historic flyby in July of 2015, which pushed the figure to approximately 1 to 8.2. Each successive measurement underscored the same conclusion. Charon was not just a large moon, it was proportionally the largest known satellite relative to its parent body anywhere in the solar system. Nothing else in the solar system came close, and nothing we had ever observed prepared us for what the spacecraft would reveal about the surfaces of these two worlds. What New Horizons revealed during that flyby made the pairing even stranger. Charon was not simply a smaller version of Pluto, it was an entirely different world. Where Pluto's surface showed geological youth and active resurfacing, Charon's terrain looked ancient, cratered, and structurally fractured. The two bodies had different colors, different compositions, different geological histories. They did not look like parent and child. They looked like two strangers who happened to share an address. New Horizons confirmed what the orbital dynamics had already implied. This was not one world with a dependent companion. This was a system of two geologically independent bodies locked in close gravitational partnership, each with its own story to tell. Other measurements deepened the strangeness further. Charon orbited at a mean distance of only approximately 19,570 kilometers from Pluto's center, a separation of roughly 16 Pluto radii. For comparison, our moon orbits at about 60 Earth radii from Earth's center. Charon was not just disproportionately large, it was disproportionately close. The two bodies occupied a compact, intimate region of space, gravitationally intertwined to a degree that stretched far beyond any normal planet-moon relationship. They were not a world and its distant satellite. They were two objects locked together in tight gravitational embrace, separated by a gap barely wider than 1.5 times the diameter of Earth. Everything about the way these two bodies relate to each other in size, mass, proximity, and mutual interaction violates the template that every other planet-moon pairing established. And here is where ordinary intuition about moons develops its first serious crack. When a moon is 1/12,000th of its planet's mass, the planet does not respond. It sits effectively motionless at the center of the system, while the moon traces a clean orbit around it. The gravitational influence flows in one direction, and the arrangement is simple. The planet holds still, the moon moves. The barycenter hides deep inside the planet where nobody has any reason to think about it. But when a moon reaches 1/8 of its planet's mass, that comfortable architecture collapses. The planet can no longer hold still. It must respond. Charon pulls on Pluto with enough force that Pluto physically moves in reaction, not slightly, not theoretically, but visibly, measurably. The two bodies do not follow the familiar template of a large stationary world with a small companion circling it. They do something else entirely, something the rest of the solar system never prepared us for. Something that becomes clear only when you stop treating Charon as a moon and start treating it as a gravitational force that Pluto cannot overpower or ignore. This is the first signal that Charon is not simply an unusually large satellite. It is a body massive enough to reshape the fundamental dynamics of the world it orbits. Every other moon in the solar system politely follows its path without disturbing its planet in any meaningful way. Charon does not do this. Charon demands a physical response from Pluto, and Pluto, small and light as it is, has no choice but to give one. But what exactly does that response look like? What happens to the physics of a system when the moon is too large and too close for the planet to hold the gravitational center? What changes when the relationship between two bodies stops being one-sided and becomes something that neither object fully controls? The answer lies in a point floating in empty space between them, a point that belongs to neither world, a point that the rest of the solar system keeps safely buried underground. And what that point reveals about Pluto and Charon is where ordinary moon logic does not just bend, it shatters. Every orbiting system in the universe has a secret. There is always a point, invisible and silent, around which everything actually revolves. It is not the center of the larger body. It is not the center of the smaller body. It is the center of mass of both bodies combined, the single point in space where the gravitational influence of the two objects perfectly balances. Physicists call this point the barycenter, and in most planetary systems, you would never know it existed because it hides inside the planet where nobody can see it and nobody needs to think about it. But in the Pluto-Charon system, the barycenter does something it is not supposed to do. It leaves the planet entirely and floats in the open vacuum between two worlds. And that single fact transforms everything about how the system moves, how it behaves, and what it even means to call one of those worlds a planet and the other a moon. To understand why this matters, you first need to understand what the barycenter normally does and why it normally stays hidden. Think of two figure skaters clasping hands and spinning together on ice. One is large and heavy, the other small and light. Both rotate around a shared point between their clasped hands, but because the heavy skater has so much more mass, that point sits very close to the heavy skater's body. If the mass difference is extreme enough, it lies inside the heavy skater's torso. The big skater barely moves while the smaller one swings wide. From a distance, it looks like the small skater is orbiting the big one. The shared rotation point is invisible, buried inside the dominant partner's body. This is how nearly every planet-moon system in the solar system works. The planet is so much more massive than its moon that the barycenter, the shared center of mass, sits deep inside the planet. The planet barely responds to the moon's gravitational pull. It remains essentially stationary while the moon traces its orbital path around it. The barycenter is there, the physics requires it, but it is functionally invisible, at ease and underground where it changes nothing about how we perceive the system. Consider Jupiter and Ganymede. The barycenter of that system sits so close to Jupiter's core that it is buried under more than 60,000 kilometers of gas and liquid hydrogen. Jupiter does not wobble because of Ganymede. The barycenter hides inside the planet like a secret that never needs to be told. Saturn and Titan follow the same pattern. The barycenter sits deep inside Saturn, indistinguishable from the planet's geometric center. The relationship is so one-sided that the concept of a shared rotation point feels academic. It exists mathematically, but changes nothing about how you experience the system. Even the Earth-Moon system, the most balanced major planet-moon pair in the inner solar system, keeps its barycenter safely underground. Earth is 81 times more massive than the Moon. The barycenter of the pair sits approximately 4,671 kilometers from Earth's center, which places it about 1,700 kilometers below Earth's surface. That is deep inside the planet's mantle, more than a quarter of the way down from the surface toward the core. Earth does wobble slightly because of the moon. The effect is real and measurable. The same gravitational pull that causes this wobble also raises the ocean tides, but the wobble is small enough that for most purposes, we can truthfully say the moon orbits Earth. The barycenter stays underground. The planet holds the center. The hierarchy is preserved. Now here is where everything breaks. Pluto is only about 8 times more massive than Charon. That ratio, 1:8, is not large enough to keep the barycenter inside the larger body. When you calculate where the shared center of mass falls for the Pluto-Charon system, the answer comes back outside Pluto entirely. The barycenter sits approximately 2,110 kilometers from Pluto's center, but Pluto's radius is only about 1,188 kilometers. The barycenter overshoots the surface by roughly 960 kilometers. It floats in the vacuum of space, a point in empty darkness that belongs to neither world, suspended in the gap between them like the fulcrum of a seesaw that has lifted off the ground. Stop and consider how strange this is. In every major planet-moon system we have ever studied, the barycenter stays safely buried underground. It hides inside the planet like an architectural foundation, hidden beneath a building, structurally essential but permanently out of sight. You would need to dig through thousands of kilometers of rock and metal and gas to reach it. The concept of the barycenter is taught in physics courses as an abstract mathematical point, something that matters for equations but that you never need to think about when looking at the actual sky. And for every planet from Mercury to Neptune, that abstraction holds. The barycenter is invisible, irrelevant to experience, a bookkeeping detail. But at Pluto, the bookkeeping detail has climbed out of the ground and is hovering in empty space for anyone with a telescope to observe. The barycenter of the Pluto-Charon system is not underground. It is not hidden. It is an actual location in the vacuum between two worlds, a point that both bodies revolve around in plain sight. This is the moment when the Pluto-Charon system stops behaving like a planet with a moon and starts behaving like something without a name. This is not a subtle technical detail. This is a fundamental change in how the system operates. When the barycenter is inside a planet, the planet is the anchor. It holds the center. It defines the system. The moon revolves around the planet. The language is simple and the physics is straightforward. But when the barycenter is outside the planet, that language collapses. Pluto does not hold the center. It cannot. The center is out there, in the space between Pluto and Charon, and both bodies revolve around it. Picture what this looks like from above. If you could hover far above the Pluto-Charon system and watch the two bodies move, you would not see a large object sitting still while a smaller one circles it. You would see both objects tracing paths around an empty point in space. Pluto swings in a small circle. Charon swings in a larger circle. Both of them orbit the same invisible pivot. The motion looks less like a planet with a moon, and more like two objects waltzing together through the darkness, each one responding to the other, each one incapable of standing still. This kind of orbital arrangement is extraordinarily rare among planets and moons. In fact, among all the confirmed planet-moon and dwarf planet-moon systems in the solar system, Pluto-Charon is the only one where the barycenter sits clearly and unambiguously outside the larger body's surface. There is one other case in the solar system where a barycenter exits a surface, and it is not a planet-moon pair at all. It is the Sun and Jupiter. Jupiter is the most massive planet in our solar system, 318 times the mass of Earth, a world so heavy it contains more than twice the mass of every other planet combined. And Jupiter is massive enough and distant enough from the Sun that the Sun-Jupiter barycenter sits just barely outside the Sun's surface, roughly 46,000 kilometers above it. But even that case is marginal. The Sun-Jupiter barycenter ratio is approximately 1.07, meaning the center of mass barely clears the solar surface. It is the cosmic equivalent of balancing a seesaw so perfectly that the fulcrum sits right at the edge of the heavier side. One tiny nudge and it falls back inside. For Pluto-Charon, the ratio is approximately 1.78. The barycenter does not barely clear Pluto, it overshoots the surface by a distance nearly equal to Pluto's entire radius. Think about what that means. Jupiter, the most powerful planet in our solar system, a world capable of warping the orbits of asteroids and comets across billions of kilometers, can only push the Sun-Jupiter barycenter a hair's width past the solar surface. Charon, a frozen world barely 1,200 kilometers across, shoves the Pluto-Charon barycenter almost 1,000 kilometers into empty space. Relative to the system it belongs to, Charon accomplishes something more dramatic than the largest planet in our solar system manages with respect to the Sun itself. The geometry of the Pluto-Charon barycenter is not just unusual. By the standards of any other system we have measured, it is extreme, and the implications go deeper than geometry. When both bodies orbit a shared external point, the gravitational dynamics of the entire system change. In an ordinary planet-moon system, you can model the planet as fixed and calculate the moon's orbit around it. The math is simple. The results are accurate. But when the barycenter is external, you cannot treat either body as fixed. Both are in constant motion. Both trace orbital paths that respond to the other. The system becomes a true binary. Two bodies locked together in mutual revolution, each one endlessly chasing a point that neither one occupies. This binary character shows up in other ways that would be invisible in a normal planet-moon pair. In the Pluto-Charon system, both bodies complete one orbit around the barycenter every 6.387 days. This period is not just the orbital period of Charon around the barycenter. It is also the orbital period of Pluto around the barycenter. It is also the rotational period of Pluto itself, and it is also the rotational period of Charon. All four numbers are identical. 6.387 days, one value governing four separate motions. Charon orbits the barycenter once every 6.387 days. Pluto orbits the barycenter once every 6.387 days. Pluto rotates on its axis once every 6.387 days. Charon rotates on its axis once every 6.387 days. Every cycle in the system is synchronized to a single shared clock. This condition is called mutual tidal locking, and it is the rarest form of gravitational synchronization known among major bodies in the solar system. To understand what it means, consider how ordinary tidal locking works. Earth's moon is tidally locked to Earth. That is why we always see the same face of the moon from the ground. The moon rotates on its axis at exactly the same rate that it orbits Earth, so the same hemisphere perpetually faces us, while the far side remains permanently hidden. This happened because over billions of years, Earth's gravity raised tidal bulges on the moon's surface. These bulges created friction as the moon rotated, gradually slowing its spin until the rotation period matched the orbital period. Once locked, the moon's orientation froze, one face toward Earth always, but this locking is one-directional. Earth is not tidally locked to the moon. Earth continues spinning freely, completing a full rotation roughly once every 24 hours, while the moon takes about 27.3 days to orbit. An astronaut standing on the moon would see Earth rotating in the sky, watching continents drift past as the planet spins. Earth is too massive for the moon's tidal forces to have slowed its rotation to match the lunar orbital period. The moon locked to Earth, but Earth did not lock back. The relationship is asymmetric. One body responded to the other body ignored it. In the Pluto-Charon system, the tidal locking goes both ways. Charon is locked to Pluto, yes. Charon always shows the same face to Pluto, just as our moon always shows the same face to Earth. But Pluto is also locked to Charon. Pluto always shows the same face to Charon. The locking is mutual, reciprocal, complete. Neither body rotates independently. Neither body shows different faces to the other over time. They are frozen in orientation relative to each other, permanently face to face, like two objects bolted together across 19,570 kilometers of empty space. This mutual lock creates a system that behaves unlike anything else among the major bodies of the solar system. Charon hangs motionless in Pluto's sky, but the lock works both ways. Stand on Charon and look back, and Pluto hangs equally motionless in return. It does not rotate. It does not shift. Its nitrogen plains and mountain ranges stay frozen in the same orientation, visible from the same vantage point, century after century, epoch after epoch. The two worlds stare at each other without blinking across a gap of nearly 20,000 kilometers. Neither one ever looks away. neither one ever shows a new face. The same hemisphere of Pluto toward the same hemisphere of Charon, perpetually, with a constancy that outlasts everything humans have ever built or imagined building. The pyramids have stood for 5,000 years. Pluto and Charon have faced each other for over 4 billion. This is profoundly different from the Earth-Moon relationship. From the Moon's surface, Earth rotates. You can watch weather systems swirl across its face. You can see the continents slide past as the planet spins. Earth is alive with motion when viewed from the Moon. But from Charon, Pluto is still. It hangs there like a photograph. And from Pluto, Charon does the same. The system is frozen in a way that no other major pair in our solar system replicates. Why did this happen? Why did Pluto lock to Charon when Earth never locked to the Moon? The answer comes back to mass ratio and proximity. Tidal locking occurs because gravity raises bulges on the surface of a rotating body. The companion's gravity pulls harder on the near side than the far side, creating a tidal bulge. But the body is still rotating, so the bulge gets carried slightly out of alignment, creating a gravitational torque that acts like a brake. Over millions and billions of years, this brake slows the rotation until the spin period matches the orbital period. The braking stops. The body is locked. The strength of this tidal braking depends on two things above all others: the mass of the perturbing companion and the distance between the two bodies. Charon is 1/8 of Pluto's mass and sits only about 16 Pluto radii away. The tidal force that Charon exerts on Pluto is strong enough, given enough time, to have drained Pluto's rotational energy and synchronized its spin with Charon's orbital period. Earth's moon, by contrast, is only 1/81st of Earth's mass and orbits at about 60 Earth radii. The tidal force is far weaker. Given the age of the solar system, the Moon has managed to lock itself to Earth, but has not had enough time or enough gravitational leverage to lock Earth back. The Moon is gradually slowing Earth's rotation through tidal friction, adding roughly 2.3 milliseconds to the length of each day per century. In billions of years, the Moon may eventually succeed in locking Earth to it, but by then the Sun will have expanded into a red giant and consumed the inner solar system long before the process completes. Pluto did not have this problem. Charon is so large and so close that mutual locking happened relatively quickly in astronomical terms, likely within the first few 100 million years after the system formed. The tidal bulges Charon raised on Pluto were enormous relative to Pluto's size. The energy dissipation was rapid. Pluto's independent rotation was doomed from the moment Charon settled into orbit. Whatever spin Pluto possessed before Charon arrived, whatever independent rotational identity it once had, was gradually erased by the relentless gravitational braking of its oversized companion. The two bodies were always going to end up locked together, face to face, sharing a single rotational period tied to a single orbital period, all governed by a single gravitational clock that neither body set alone. And the result is a system that does not behave like a planet with a moon. It behaves like a single gravitational unit. Two worlds locked in permanent embrace, orbiting a shared point in empty space, synchronized down to the same 6.387-day cycle. Pluto does not own this system the way Jupiter owns its moons or Saturn presides over its rings. Pluto shares this system with Charon. They are co-equal participants in a gravitational relationship that neither one dominates. This is why some planetary scientists have described the Pluto-Charon pair as a binary system rather than a planet-moon system. Binary systems are common among stars. Roughly half of all star systems in the Milky Way are binaries, two stars orbiting a shared center of mass. The physics is identical. Two objects, gravitationally bound, orbiting a barycenter that may sit between them rather than inside either one. When astronomers look at the Pluto-Charon system, they see orbital mechanics that resemble a binary star more closely than they resemble Jupiter and its moons. The language of planet and satellite starts to feel inadequate. The system demands a different vocabulary, and this is not a fringe position. The terminology of planet and moon carries an assumption of dominance that the Pluto-Charon system does not support. Several planetary scientists have argued that the pair should be reclassified as a binary or double dwarf planet, pointing to the external barycenter and the mutual tidal lock as evidence that the hierarchy has dissolved. The debate remains formally unresolved. No official criterion separates a double planet from a planet-moon pair. Charon is still classified as a moon of Pluto, but only by default, because no alternative has been adopted. The question of what to actually call this system sits at the intersection of physics and language, and neither discipline has produced a satisfying answer. Other binary-like pairings have been discovered in the outer solar system, hinting that the Pluto-Charon arrangement may not be entirely unique. The dwarf planet Eris has a moon called Dysnomia that may itself be tidally locked. The dwarf planet Candida Orcus has a moon called Vanth whose mass ratio could approach binary territory. The object Salacia has a companion called Actaea. In some of these systems, the mass ratios may approach what we see with Pluto and Charon, though precise measurements remain extraordinarily difficult at such extreme distances because the objects are so faint and so far away. But none of these systems have been studied with anything close to the detail that New Horizons provided for Pluto and Charon. For now, the Pluto-Charon pair remains the best characterized binary-like system in the solar system, and the only one where mutual tidal locking has been definitively confirmed among major bodies of this size. The mutual lock has another consequence that goes beyond dynamics. It defines the emotional character of the system. Every other planet in the solar system rotates independently of its moons. Earth spins through day and night cycles regardless of where the moon is. Mars rotates on its own schedule while Phobos and Deimos race and crawl across its sky. Jupiter's 10-hour rotation has nothing to do with the orbital periods of its satellites. These planets have their own rhythms, their own independent identities, their own sense of self that exists apart from anything orbiting them. Pluto has no independent rhythm. Its rotation is Charon's orbit. Its day is Charon's year. Every temporal cycle that defines Pluto as a spinning world in space is dictated by its relationship to Charon. Remove Charon from the system, and Pluto's current rotation rate has no explanation. It was set by Charon, shaped by Charon, locked into place by Charon's gravitational pull over billions of years of tidal friction. Pluto's very sense of time, how long its day lasts, how it orients itself in space, is a product of the moon that orbits it. If Pluto had never acquired Charon, it would spin at a completely different rate, perhaps much faster, perhaps with a different axial tilt. The Pluto we observe today, the one with a 6.387-day rotation period and a specific orientation toward the Sun, is not the Pluto that would have existed alone. It is the Pluto that Charon made. No other planet or dwarf planet in the solar system has surrendered its rotational identity to a satellite this completely. Earth's spin was influenced by the moon, slowed over billions of years, but Earth still rotates independently, still has its own day length and its own temporal identity. Pluto does not. Pluto's day belongs to Charon, set by mutual gravity, not by either body alone. This level of synchronization has physical consequences that cascade through the system. Because both bodies are locked and both orbit the external barycenter, the tidal forces between them have reached equilibrium. No energy is being exchanged through tidal friction anymore. The orbit is essentially circular, with an eccentricity so close to zero that it took precision measurements from Earth-based observatories to confirm it. The system has reached its final dynamical state. It is not evolving. It is not changing. It is finished. The cosmic waltz reached its final choreography billions of years ago, and has been repeating the same steps ever since. This tidal equilibrium is called a doubly synchronous state, and among major bodies in the solar system, Pluto-Charon is the only confirmed example. It is the endpoint of tidal evolution, the final resting state that every tidally interacting system is theoretically heading toward, but that almost none ever reach, because the timescales involved are too long or the mass ratios too extreme. If the Earth-Moon system could survive long enough, it would theoretically evolve toward a doubly synchronous state. But the timescale required would be tens of billions of years, and the Sun will expand into a red giant and likely destroy the system in roughly 5 billion. The process will never finish. Pluto and Charon faced no such obstacle. They arrived at their destination billions of years ago and have been sitting in perfect synchrony ever since. The result is a system that is eerily still, no tidal heating, no orbital decay, no gradual spiraling inward or outward. Pluto and Charon are locked in place, separated by the same distance, spinning at the same rate, orbiting the same invisible point in space, facing each other with the same hemispheres, repeating the same 6.387-day cycle without variation. The system is a gravitational clock that has been keeping perfect time since long before humans existed and will keep ticking long after our sun has burned out. And this raises a question that the dynamics alone cannot answer. How did such a system form? How did two bodies of such similar size end up in such an extreme gravitational configuration, locked together at the edge of the solar system, in a relationship that has no parallel among the major planets? The size ratio is extraordinary. The barycenter geometry is extraordinary. The mutual tidal lock is extraordinary. Everything about this pair suggests an origin story that must be as unusual as the system itself. The question is not just how Charon got there. The question is how anything this strange could have come into existence at all. Something must have happened in the distant past of the solar system, something violent and precise, to produce a pairing this extreme. Two objects of this size do not simply drift together and settle into a mutual tidal lock by chance. The physics demands an event, a moment of creation that set the entire system into motion. And when scientists finally modelled what that event might have looked like, the answer turned out to be as extraordinary as the system it produced. A system this strange demands an origin story to match. Two worlds locked face to face, orbiting an invisible point in empty space, synchronized down to a single shared period, with a mass ratio unlike anything else among the major moons and planets of the solar system. This arrangement did not happen gradually. It did not assemble itself through gentle gravitational capture or slow accretion over millions of years. Something violent had to create it. Something fast and catastrophic had to throw enough mass into orbit around Pluto to produce a companion half its size. Scientists have spent decades trying to understand what that event was, and the answer has evolved dramatically, most recently in a study published in early 2025 that rewrote the formation story in ways nobody expected. The starting point for understanding how Charon formed is a parallel much closer to home. Earth's moon is thought to have originated from a giant impact approximately 4.5 billion years ago, when a Mars-sized body called Theia struck the early Earth at an oblique angle. The collision was catastrophic. It vaporized portions of both objects, ejecting a cloud of molten rock and debris into orbit around the battered Earth. Over time, that debris coalesced into the moon we know today. This giant impact hypothesis, first proposed in the 1970s and refined through decades of computer simulations, became the leading explanation for the moon's origin because it resolved several otherwise puzzling features, from the moon's small iron core to the near-identical isotopic compositions of Earth and lunar rocks. When scientists turned their attention to the Pluto-Charon system, the giant impact model seemed like a natural fit. The parallels were obvious. Both systems feature a satellite that is unusually large relative to its parent body. Both systems have high angular momentum, meaning the pair spins with more rotational energy than you would expect from a single object. And both systems are difficult to explain through other formation mechanisms. Gravitational capture, where a passing body is grabbed by a planet's gravity, has traditionally been proposed for small, irregular moons like those orbiting the giant planets. Small objects on tilted, elliptical orbits fit the profile of strays that wandered too close and got trapped. But capture becomes increasingly implausible as the companion body gets larger relative to the planet it approaches. A body half the size of Pluto approaching at typical Kuiper belt encounter velocities would carry enormous kinetic energy. For Pluto's gravity to capture it, that energy would need to be dissipated somehow, absorbed by tidal deformation, transferred to a third body, or radiated away. For an object as massive as Charon, the energy budget simply does not work. The incoming body would whip around Pluto on a hyperbolic trajectory and continue out into the Kuiper belt, never to return. Simple gravitational capture cannot explain Charon. Something more dramatic was required. A giant impact solves this problem by creating Charon from the collision itself. In the traditional version of the hypothesis, a large Kuiper belt object struck Pluto billions of years ago. The impact was energetic enough to eject a massive cloud of debris into orbit. That debris then gathered together through its own self-gravity, eventually forming Charon, This scenario was modeled in detail by planetary scientist Robin Canup, who published influential simulations in 2005 showing that a collision between two comparably sized icy bodies could produce a system resembling Pluto-Charon. In her models, the impactor was roughly 1,000 kilometers across and struck Pluto at a glancing angle. The collision disrupted the impactor and ejected a massive disk of debris into orbit around the surviving Pluto, and that disk condensed into Charon over a period of hours to days. The Canup model was a significant achievement. It demonstrated that the giant impact mechanism could produce the right mass ratio and angular momentum for the Pluto-Charon system, but it had a limitation that nagged at researchers for years. In these simulations, the collision was violent enough that the impactor was largely destroyed and its material scattered into a disk around Pluto, which itself survived mostly intact. Charon, in this picture, was not a surviving body. It was a new object, assembled from the shattered remains of the impactor and some of Pluto's outer layers. This meant that Charon's internal structure, its core, its mantle, its compositional layering, should reflect a history of disruption and reassembly rather than preservation. Any original structure the impactor possessed would have been erased. But the data from New Horizons complicated this picture. When the spacecraft flew through the Pluto system in July of 2015, it revealed that both Pluto and Charon appeared to be geologically differentiated, meaning they had distinct layers with denser material at the center and lighter material toward the surface. Charon in particular showed evidence of a structure that looked ancient and relatively undisturbed. Its surface was heavily cratered in some regions, suggesting great age. Its enormous tectonic rift system, stretching roughly 1,000 kilometers across the Moon's face, hinted at deep internal processes early in its history, possibly the freezing and expansion of a subsurface ocean. These features were consistent with a body that had retained much of its original architecture, rather than one that had been completely shattered and rebuilt from debris. This tension between the traditional impact model and the observed geological evidence set the stage for a new hypothesis that arrived in January of 2025. A team led by planetary scientist Adine Denton, then a postdoctoral researcher at Southwest Research Institute, published a study in Nature Geoscience that proposed a fundamentally different mechanism for Charon's formation. The team called it kiss and capture. The key innovation in Denton's work was the inclusion of material strength in the impact simulations. Previous models, including Canup's, had treated Pluto and the impactor as fluid bodies, objects that deform and flow like liquids under the extreme pressures of a giant collision. This is a reasonable approximation for large, warm, rocky bodies like the early Earth and Theia, where internal temperatures are high enough that rock behaves plastically under impact. But Pluto and the impactor were icy bodies in the cold outer solar system. Ice at the temperatures found in the Kuiper belt is not soft. It is rigid. It is strong. It resists deformation in ways that warm rock does not. By including this material strength in their simulations, Denton's team discovered an entirely new regime of giant impact outcomes that previous models had missed. In the kiss and capture scenario, a Charon-sized body approaches Pluto and strikes it at a grazing angle, similar to the geometry in traditional giant impact models. But instead of shattering both objects into a debris cloud, something different happens. The two icy bodies collide and stick. Friction between their surfaces distributes the impact momentum, and the two objects become temporarily connected. They form a single elongated structure, like a snowman, two spheres joined at a narrow contact point. This merged body rotates as a unit for a period of hours, spinning together through space, but the material strength of the ice prevents the two bodies from fully merging. They do not blend into one object. They do not collapse into a single sphere. The structural integrity of both bodies resists coalescence. Then tidal forces from Pluto's rotation begin to pull the pair apart. The contact point stretches. The joined structure separates. Charon is pushed outward into a close orbit around Pluto, largely intact. Its core survives. Most of its mantle survives. Charon emerges from the collision not as a rebuilt debris object, but as an ancient body, possibly as old as Pluto itself, captured into orbit through a brief, violent embrace. The entire encounter, from first contact to separation, unfolds over a matter of hours. A formation event lasting less than a single day on Earth produced a binary system that has persisted for over 4 billion years. From that initial close orbit, tidal forces then gradually expanded Charon's distance from Pluto over hundreds of millions of years, pushing it outward to its current separation of approximately 19,570 kilometers, while simultaneously driving both bodies toward the mutual tidal lock that defines the system today. The process is slow but inexorable. Tidal friction transfers rotational energy into orbital energy, and the orbit grows. The same mechanism is happening right now with Earth's moon, which recedes from Earth by approximately 3.8 centimeters per year. For Pluto and Charon, the process ran to completion long ago. The orbit expanded, the tidal lock set in, and the system settled into the frozen configuration we observe today. The kiss and capture model also has implications that extend far beyond Pluto. If this mechanism works for icy bodies in the Kuiper belt, it could explain the formation of other large binary systems among trans-Neptunian objects. The outer solar system contains dozens of known binary pairs among its icy population. Many of these binaries have mass ratios and separations that are difficult to explain through traditional capture or giant impact models. Kiss and capture, with its emphasis on the structural strength of cold ice, offers a potential explanation for how these systems came into being. The mechanism may not be unique to Pluto. It may be a common pathway for binary formation in the cold outer reaches of the solar system. The kiss and capture model is a leading new hypothesis, not yet a scientific consensus. It was published in one of the most rigorous journals in planetary science and has drawn significant interest, but it has not yet been replicated by independent groups, and its predictions about Charon's internal structure remain to be tested against future observations. The scientific process of verification is ongoing. What is confirmed, regardless of which formation model ultimately prevails, is that the Pluto-Charon system was born from violence. Whether Charon was rebuilt from debris or captured intact through a grazing collision, the system required a giant impact to come into existence. Two large icy bodies had to meet in the darkness of the early Kuiper belt, collide at precisely the right angle and velocity, and produce an outcome that placed enough mass into orbit to create the most extreme moon-to-planet ratio in the solar system. The odds of this precise outcome were not high. Giant impacts between Kuiper belt objects of comparable size were more common in the early solar system than they are today, when the population has thinned by more than 99% and surviving objects are spread across vastly larger volumes of space. But even in that busier era, the specific geometry required to produce a stable binary with the Pluto-Charon mass ratio was far from guaranteed. The Pluto-Charon system is a product of chance, a cosmic accident whose likelihood was low, but whose consequences were permanent. But the collision did not just create Charon, it created an entire system, and the evidence for that system orbits the Pluto-Charon barycenter right now in the form of 4 tiny moons that most people have never heard of, but that tell the full story of what the Pluto-Charon binary really means for the space around it. Styx, Nix, Kerberos, and Hydra. 4 small, irregularly shaped worlds of ice, each one smaller than a mid-sized city, orbiting in the gravitational architecture built by Pluto and Charon. Nix and Hydra were discovered first, spotted in Hubble Space Telescope images in 2005 by a team preparing for the New Horizons mission. The discovery was significant not only because it added to Pluto's moon count, but because the researchers were specifically searching for potential hazards that might threaten the spacecraft during its flyby. The fact that the system contained additional objects hinted at a more complex orbital environment than anyone had appreciated. Kerberos followed in 2011, found during a dedicated search for rings and additional satellites. Styx, the smallest and innermost, was found in 2012, barely a year before the point of no return for New Horizons trajectory planning. All 4 were discovered in the same way, as faint dots of reflected light hovering near Pluto in deep Hubble exposures, so dim that they had escaped detection for decades despite being present in the data all along. Their sizes are modest by any standard. Nix measures roughly 49 kilometers along its longest axis, with an irregular elongated shape more like a jelly bean than a sphere. Hydra is the largest of the 4, approximately 52 kilometers long, equally misshapen, Kerberos stretches about 19 kilometers across. Styx, the tiniest, spans barely 10 kilometers. These are not worlds in any meaningful sense. They are fragments, boulders, cosmic rubble. Compared to Charon's 1,212-kilometer diameter, they are specks of dust orbiting two much larger objects. But their orbits tell a story that changes how you understand the entire Pluto system. All 4 small moons orbit in the same plane as Charon. With eccentricities so close to zero, their paths are essentially perfect circles and inclinations of less than half a degree. They are aligned, organized, precisely arranged. Captured moons, like the small irregular satellites of Jupiter and Saturn, orbit at steep angles on wildly elliptical paths. Pluto's small moons look disciplined, and here is the detail that transforms the picture. They do not orbit Pluto. They orbit the Pluto-Charon barycenter. Their paths circle the same invisible point in empty space that Pluto and Charon themselves revolve around. The 4 small moons are not satellites of Pluto. They are satellites of the binary system. They belong to the pair, not to either individual body. Their orbital architecture is organized around the gravitational center of mass of 2 worlds, not around the center of one. This distinction matters enormously. If the small moons orbited Pluto's center, you could still argue that Pluto is the dominant object in the system, and that Charon is just an unusually large moon. But the small moons do not recognize Pluto as the center of anything. They orbit the barycenter. They treat Pluto and Charon as a single gravitational unit, a combined system whose center of mass is the true organizational anchor. The small moons see what the dynamics have been telling us all along. This is not a planet with a moon. This is a binary system, and everything in it orbits accordingly. The orbital periods of the small moons reveal another layer of organization that deepens this impression. Styx completes one orbit in approximately 20.2 days. Nix takes about 24.9 days. Kerberos requires roughly 32.2 days. Hydra orbits in approximately 38.2 days. Compare these to Charon's orbital period of 6.387 days. The ratios come out to approximately 3:1 for Styx, 4:1 for Nix, 5:1 for Kerberos, and 6:1 for Hydra. 3, 4, 5, 6. The small moons are spaced at nearly perfect whole number multiples of the Pluto-Charon orbital period, stacked in a sequence so clean it looks deliberate. These near resonances are not coincidences. They are not random alignments that happen to look organized. They are signatures of a system that arranged itself gravitationally around the central binary over millions of years. Resonances in orbital mechanics are powerful organizing forces. When a small body's orbital period aligns with a whole number multiple of a larger body's period, the 2 objects meet at the same relative positions during each orbit. This creates repeating gravitational interactions that can either stabilize or destabilize the smaller body's orbit depending on the geometry. In the Pluto-Charon system, the near-resonant locations turned out to be islands of stability in an otherwise chaotic gravitational landscape. When Pluto and Charon settled into their mutual orbit after the giant impact, the debris left over from the collision spread outward. Particles that happened to orbit at periods near whole number multiples of the Pluto-Charon period experienced regular gravitational kicks that reinforced their orbits, pushing them toward those resonant distances. Particles at other distances experienced disruptive forces that scattered them or drove them into unstable trajectories. Over millions of years, the surviving debris accumulated at the resonant locations, eventually coalescing into the 4 small moons we observe today. The system sorted itself. The binary carved gravitational channels into the surrounding space, and the small moons settled into those channels like marbles finding the grooves in a track. This resonant architecture is strikingly similar to how circumbinary planets orbit binary star systems. In stellar binaries, planets form in disks of gas and dust surrounding both stars. The gravitational influence of the central binary creates zones of stability and instability, and planets preferentially form in the stable zones, often near resonant orbital periods. The Pluto-Charon system is doing the same thing on a much smaller scale. Its small moons are circumbinary satellites, orbiting a central binary according to the same gravitational rules that govern planetary formation around binary stars. The parallel is not metaphorical. It is mathematical. The equations are identical. The physics does not care whether the central objects are stars or icy dwarf planets. The organizational principle is the same, but the binary's influence on the small moons goes beyond just setting their orbital distances. It also scrambles their rotations in a way that has no parallel anywhere else in the solar system except one obscure moon of Saturn. Most moons in the solar system rotate in a predictable, orderly fashion. They are tidally locked to their parent planets, always showing the same face, spinning once per orbit in a stable, synchronous state. This is the default outcome of tidal evolution for any moon that has orbited long enough for gravitational friction to synchronize its spin. You would expect Pluto's small moons to follow the same pattern, tidally locked to the central binary, rotating in calm synchrony with their orbital periods. They do not. Nix, Hydra, Kerberos, and Styx all rotate chaotically. They tumble. Their spin axes point in unpredictable directions. Their rotation rates are not synchronized with anything. Hydra, the outermost, spins once approximately every 10 hours, while orbiting once every 38 days. That means Hydra rotates roughly 89 times during a single orbit. It is spinning wildly, like a football tumbling end over end through the air, completing nearly 90 full rotations between one lap around the barycenter and the next. Nix is even more disorienting. Its rotation axis is tilted so severely relative to its orbital plane that the Sun could rise in the east and set in the north. Its pole orientation has been measured at approximately 132 degrees from the Pluto-Charon equatorial plane, meaning it spins in a retrograde direction, backwards compared to its orbital motion, and its spin rate has changed measurably since its discovery, accelerating by roughly 10% over the span of observations. The rotation is not just chaotic, it is actively evolving, shifting in speed and orientation, as the gravitational field of the binary continues to torque the moon's elongated body in unpredictable ways. Mark Showalter of the SETI Institute, who led the study that discovered this chaotic behavior, put it simply: if you lived on Nix, you would not know if the Sun is coming up tomorrow. The cause of this chaos is the binary itself. Pluto and Charon orbit each other every 6.387 days, and as they do, the gravitational field experienced by the small moons constantly changes. The gravitational pull is not steady. It oscillates. It shifts direction. The binary acts like a gravitational dumbbell, rotating in the center of the system, sending pulses of varying gravitational force outward with each revolution. For a perfectly spherical moon, these oscillations would average out and the rotation would remain stable. But the small moons are not spherical. They are elongated, irregular, shaped like potatoes and jelly beans. Their non-spherical shapes give the oscillating gravity something to grab onto. The varying gravitational torques push and pull on the elongated bodies, speeding up their rotations, slowing them down, flipping their axes. The result is chaos. Permanent, ongoing, gravitationally induced chaos that will last as long as the binary keeps spinning, which is to say, forever. Only one other moon in the entire solar system is known to tumble chaotically: Hyperion, a small irregular moon of Saturn, roughly 270 kilometers across. But Hyperion's chaos is caused by a different mechanism: its orbital resonance with the much larger moon Titan. Gravitational kicks from Titan's orbit disrupt Hyperion's rotation on each close approach. The chaos at Pluto is fundamentally different. It is not caused by a nearby larger moon. It is caused by the binary nature of the central system itself. The gravitational dumbbell of Pluto and Charon creates a dynamic, pulsating gravitational environment that prevents the small moons from ever settling into stable rotation. They cannot lock. They cannot synchronize. The floor beneath them is constantly tilting, and no amount of time will make it stop. The binary does not just organize the orbits of the small moons into resonant positions, it also scrambles their spins into permanent disorder. Order and chaos coexist in the same system, produced by the same gravitational cause, two contradictory outcomes of a single organizing principle. Step back now and look at the full picture of what the Pluto system actually is. It is not a dwarf planet with a big moon and 4 small ones. It is a gravitational system organized around a binary core. At the center, Pluto and Charon orbit their shared barycenter in mutual tidal lock, face to face, synchronized to a single 6.387-day period. Around that binary core, 4 tiny moons trace nearly circular, nearly coplanar orbits at distances that correspond to near integer multiples of the central period. Those moons orbit the barycenter, not Pluto. Their orbital architecture is shaped by the binary. Their rotational chaos is driven by the binary. Everything in the system, every orbit, every spin, every resonance, every instability, traces back to the fact that the center of this system is not a single world, it is a pair. This is what makes the Pluto system more than just an oddity in the outer solar system. It is not merely that Charon is unusually large, it is that Charon's presence reorganizes everything around it. Pluto alone would be a simple dwarf planet, with perhaps a handful of small captured moons orbiting in random directions on elliptical paths. Unremarkable, unmemorable, one Kuiper Belt object among thousands. But Pluto with Charon is a fundamentally different object. It is a system, a structured, organized, dynamically rich system built around a binary core, with circumbinary satellites arranged in resonant orbits, tumbling through a gravitational field that no single body could produce. The 4 small moons are the forensic evidence. They prove that the Pluto-Charon binary is not just an interesting pairing between 2 objects that happen to be near each other. It is the organizing principle of the entire system. Their orbits are the fingerprints the binary left on the surrounding space. Their chaos is the signature of a gravitational environment that no lone planet creates. Remove Charon, and the 4 small moons would not exist in their current configuration. Their resonant spacing would have no cause. Their chaotic tumbling would have no driver. Their coplanar orbits would have no template. The system would collapse into something ordinary and forgettable. Without Charon, none of it exists. And if Charon shapes the system's architecture, and if Charon dictates Pluto's rotation, and if Charon pulls the barycenter out of Pluto's body, and if everything in the system orbits the pair rather than the planet, then a question begins to form that is harder to answer than any question about orbits or mass ratios or tidal forces. What is Pluto, really? Is it a planet with a moon? Is it one half of a binary? Is it the dominant body in its own system? Or has it surrendered so much of its gravitational authority, its rotational independence, its structural centrality, to Charon that it no longer makes sense to think of it as a standalone world at all? The dynamics have already answered this question. The small moons have already answered it. The barycenter has already answered it. Everything in the system points to the same conclusion. But saying it out loud, putting it into words that carry the emotional weight of what the physics actually implies, requires confronting something that feels stranger than any orbital calculation. It requires confronting what Charon has done to Pluto's identity. There is a photograph that nearly everyone on Earth has seen. A tiny point of pale light, hanging in a field of absolute darkness. It was taken by the Voyager 1 spacecraft in 1990 from a distance of roughly 6 billion kilometers at the suggestion of Carl Sagan. The image became known as the pale blue dot, Earth reduced to a fraction of a single pixel, barely visible against the black void, a speck of light caught in a sliver of scattered sunlight. That photograph changed how millions of people understood their own world. The planet they walked on every day, the ground they assumed was vast and permanent, was revealed to be almost nothing when seen from far enough away. The meaning of Earth changed not because Earth itself changed, but because the frame of reference expanded. Context rewrote identity. Something similar happens with Pluto when you finally see it alongside Charon. Not the Pluto of popular imagination, the small, lonely outcast drifting at the edge of the solar system, the plucky underdog that got demoted from planehood in 2006. That Pluto is a character in a cultural story. It is the Pluto that schoolchildren mourned when the International Astronomical Union voted to reclassify it as a dwarf planet. It is the Pluto that inspired bumper stickers reading, "Pluto is still a planet in my heart." That Pluto is a single object, a solitary world, defined by its isolation and its underdog status. And that Pluto does not exist. The real Pluto has never been alone. From the moment Charon was captured into orbit roughly 4.5 billion years ago, Pluto stopped being a single world. Its rotation was reshaped. Its gravitational center was pulled out of its own body. Its orbital behavior became inseparable from the companion that circles it. The Pluto that exists in physical reality is not a lone dwarf planet with a moon trailing behind it like a loyal pet. It is one half of a gravitationally bound pair, and it has been one half of that pair for nearly the entire history of the solar system. This is not how we talk about Pluto. It is not how we think about it. When most people picture the solar system, they see 8 planets orbiting the Sun, and then, somewhere out beyond Neptune, a small icy ball called Pluto. Maybe they remember that Pluto has moons. Maybe they recall that the biggest one is called Charon. But the mental image is always Pluto first, singular, independent, and Charon second. Somewhere in the background, a footnote to the main character. The emotional weight lands on Pluto as an individual. Charon is an accessory, a piece of trivia, an afterthought in every poster, every model, every diagram that hangs in science classrooms around the world. We have been telling ourselves a story about Pluto for nearly a century. It was discovered in 1930 by Clyde Tombaugh after a painstaking photographic search at the Lowell Observatory in Arizona. An 11-year-old English girl named Venetia Burney suggested its name after the Roman god of the underworld. Pluto became the 9th planet, the outermost sentinel, the cold, lonely wanderer at the edge of known space. Generations of children grew up memorizing it as the last entry in the planetary lineup. It became a character, not just a celestial body, the runt of the litter, the little planet that could. When the International Astronomical Union voted to reclassify it in 2006, the public outcry was driven not by science, but by affection. People did not defend Pluto's planetary status because they understood orbital mechanics. They defended it because they had grown attached to the idea of a brave little world, holding its place at the frontier. The demotion felt personal. It felt like losing a member of the family. But the demotion debate missed something. It argued about what label to put on one object. It argued about whether Pluto, singular, deserved to sit in the same category as Jupiter and Earth. Nobody in that debate stopped to ask whether Pluto was truly singular in the first place. But every piece of evidence tells the opposite story. Charon is not an accessory. Charon is the reason the Pluto system behaves the way it does. Remove Charon and the barycenter falls back inside Pluto. Remove Charon and Pluto spins at whatever rate its original formation gave it, no longer tidally braked into a 6.387-day period. Remove Charon and the 4 small outer moons lose their resonant orbits, their coplanar alignment, their chaotic tumbling. Remove Charon and Pluto becomes ordinary. One more icy dwarf planet among thousands of Kuiper belt objects, unremarkable, indistinguishable from dozens of similar worlds drifting through the cold outer reaches of the solar system. Eris, Haumea, Markai, Sedna, Qua-OR. None of these other dwarf planets or dwarf planet candidates have captured the human imagination the way Pluto has. And the reason Pluto stands out is not because of Pluto alone. It is because of what Pluto becomes when paired with Charon. Remove the pairing and the magic disappears. It is Charon that makes Pluto extraordinary. And that means Pluto's identity as a strange, compelling, category-defying world is not intrinsic. It is relational. Pluto is interesting because of what it is paired with, not because of what it is alone. This realization cuts against something deep in how we organize the solar system in our minds. We think of worlds as individuals. Mercury is the scorched innermost planet. Venus is the greenhouse nightmare. Earth is the blue marble. Mars is the red desert. Jupiter is the gas giant king. Each planet has a singular identity, a personality defined by its own properties, its own atmosphere, its own geology, its own distance from the Sun. We do not define Jupiter by its relationship to Ganymede. We do not define Saturn by its relationship to Titan. Those moons are interesting in their own right, scientifically valuable, worthy of entire missions and careers. But the planets exist independently of them. The identity flows from the planet outward. The moons are secondary characters in stories that belong to the planets. Pluto breaks this pattern completely. You cannot define Pluto without Charon. You cannot describe its rotation without Charon. You cannot explain its barycenter geometry without Charon. You cannot account for the orbital architecture of its satellite system without Charon. Try to write a complete physical description of Pluto, covering its rotation rate, its orientation in space, its gravitational center, its dynamical environment, and Charon appears in every paragraph. The two objects are so intertwined that a textbook entry on Pluto that does not prominently feature Charon is not merely incomplete, it is misleading. It gives the impression of a self-contained world when the reality is a world whose most fundamental properties are shared with another body. Pluto's identity is not self-contained. It spills over into the companion that shares its gravitational center, and Charon's identity spills back. The two are so deeply entangled that separating them into planet and moon feels like an act of distortion, a simplification that conceals the most important thing about either of them. This is what it means to say that Charon makes Pluto stranger than a planet. Charon makes Pluto stranger than a planet, not because Charon is big, although it is, not because the barycenter floats in empty space, although it does, not because the system is mutually tidally locked, although that is true. Charon makes Pluto stranger than a planet because it changes what Pluto is. A planet is a singular entity. It has its own gravity, its own rotation, its own identity. Pluto has surrendered all of these to a shared relationship with Charon. Pluto is not a planet in any emotional or structural sense, but it is not simply a dwarf planet with a moon, either. It is something else. Something the solar system does not have a clean word for. The double planet label has been applied to the Pluto-Charon system for decades. Many planetary scientists use the term informally. Some use it in published papers. The logic is straightforward. If both bodies orbit an external barycenter, if both are tidally locked to each other, if the mass ratio is close enough that neither body completely dominates, then calling one the planet and the other the moon is arbitrary. You could just as easily call Pluto the moon of Charon. The system does not care which label goes where. The physics is symmetric enough that the hierarchy dissolves. But the International Astronomical Union has never formally defined what a double planet is. No official criterion exists. When the famous vote happened in 2006, the one that stripped Pluto of its planetary status, an early draft of the resolution actually included a provision that would have classified Pluto and Charon as a double planet. Under that draft, Charon would have been promoted from moon to planet in its own right, and the pair would have been recognized as a binary system. The provision was removed before the final vote. It was too controversial. It raised too many questions about other borderline cases. The International Astronomical Union chose the simpler path. Pluto was demoted. Charon remained a moon. The harder question, the one about what the pair actually is, was left unanswered. It remains unanswered today. And this is not because scientists lack data. It is because the data does not map onto existing categories. The solar system offers us two clean templates for how a large body and a smaller body can relate. In the first template, the planet dominates. The moon is tiny. The barycenter is deep underground. The planet holds the center and the moon orbits obediently. This describes every planet from Mercury to Neptune and their moons. In the second template, two bodies of comparable mass orbit, a shared center. This describes binary stars, which are enormously common in the galaxy. Roughly half of all star systems contain two or more stars orbiting each other. Pluto and Charon fit neither template perfectly. Pluto is 8 times more massive than Charon, which is enough of an imbalance that calling them equals feels inaccurate. Charon is genuinely the smaller, less massive body, but the imbalance is not severe enough for the planet-moon template to hold. The barycenter is outside Pluto. The tidal lock is mutual. The satellite system orbits the pair, not the larger body. The system behaves like a binary, but not quite. It behaves like a planet with a moon, but not quite. It sits in a gap between categories that the solar system never forced us to define before. This gap is not a failure of classification. It is a feature of nature. The universe does not organize itself according to human categories. It produces objects and systems along continuous spectra, and sometimes those spectra pass through regions where no existing label fits. Pluto and Charon occupy exactly such a region. They are too imbalanced to be a perfect binary, too balanced to be an ordinary planet-moon pair, too dynamically entangled to be treated as separate objects, and too physically distinct to be treated as one. The system resists every label we try to pin on it, And that resistance is itself the most honest description of what the Pluto-Charon pair actually is. Consider what it would look like if Earth had a companion of equivalent proportions. Scale Charon's relationship to Pluto up to Earth's size. An Earth-equivalent Charon would be roughly 6,000 kilometers in diameter, nearly as wide as Mars. It would orbit at a distance of approximately 105,000 kilometers, barely more than a quarter of the distance to our Moon. The barycenter of the pair would sit thousands of kilometers above Earth's surface, floating in space. Earth and this hypothetical partner would be mutually tidally locked, both always showing the same face to each other, both rotating once every few days rather than once every 24 hours. The tides would be immense, coastal geography would be unrecognizable, and the sky would be transformed. From the companion-facing hemisphere, you would look up and see a sphere so large it would fill a substantial arc of your visual field, hundreds of times larger in apparent size than the Moon we know. It would hang motionless, never rising, never setting, a permanent presence in the sky above your head. Its surface features would be visible to the naked eye, mountain ranges and plains and craters, a world you could study without a telescope simply by looking up. From the opposite hemisphere you would never see it at all. Half the planet would live under a companion world and half would live in ignorance of it. Nobody would call that object a moon. Nobody would look at that pair and say one orbits the other. You would see two worlds, side by side, locked together, sharing a gravitational center that belongs to neither. You would call it a double planet without hesitation, because the visual and dynamic reality would make any other label feel absurd. That is how Pluto and Charon actually work. The only reason we still call Charon a moon is that we encountered the system from such an enormous distance that both objects appeared as a single smeared dot on a photographic plate. We named the larger dot the planet and the smaller dot the moon, and the language stuck. But the language was wrong from the start. We were describing the system before we understood it, and now that we understand it, the old description no longer fits. The New Horizons flyby in 2015 made this mismatch visceral. When the spacecraft sent back its first high-resolution images, scientists and the public alike saw something that no textbook illustration had prepared them for. Pluto and Charon were not variations on a theme. They were two completely different worlds. Pluto's surface was geologically young in places, resurfaced by active processes, painted in tans, reds and whites. Its vast nitrogen glacier filled a basin the size of Texas. Mountains of water ice towered along the glacier's edge. Haze layers in its thin nitrogen atmosphere caught the sunlight in ways that made the dwarf planet look hauntingly Earth-like from certain angles. Charon looked nothing like this. Its surface was older, more heavily cratered, dominated by greys and dark reds. A vast system of canyons and fractures split its face, evidence of ancient tectonic forces driven by the freezing of a subsurface ocean early in Charon's history. Its north pole wore a dark reddish-brown cap, a deposit of organic compounds processed by ultraviolet light from material that had escaped Pluto's atmosphere and settled onto Charon's frigid surface. The two worlds were not parent and child. They were not original and copy. They were two distinct geological individuals, each with its own history, its own surface processes, its own story of internal evolution, locked together across 19,000 kilometers of empty space. This geological distinctness deepens the identity problem. If Charon were simply a chunk that broke off from Pluto, you might expect them to look similar, like two pieces of the same shattered rock. If Charon had formed from a debris disk in Pluto's orbit, you might expect significant compositional overlap, the way Earth and the Moon share similar isotopic signatures. But Pluto and Charon look different enough, feel different enough, and tell different enough geological stories to have had substantially independent evolutionary lives. Pluto is geologically active, resurfacing itself through processes that are still not fully understood at such cold temperatures and such small scales. Charon appears geologically dead, its surface ancient and cratered, its last major activity occurring billions of years ago, when its interior froze and expanded, cracking its crust into the vast canyon system that scars its face. They are partners, not copies. Each one brought its own materials, its own internal heat budget, its own evolutionary trajectory to the relationship. The system is not one world split in two. It is two worlds that were never one, bound together by an ancient collision and held in permanent embrace by mutual gravity. And this is where the strangeness reaches its deepest point. Pluto is not merely unusual because of its size, its distance from the Sun, or its eccentric orbit. Pluto is unusual because it is incomplete without Charon. Every other object in the solar system that we call a planet or dwarf planet can be understood on its own terms. You can study Mars without reference to Phobos and Deimos and miss nothing essential about what Mars is. You can study Neptune without mentioning Triton and still capture Neptune's fundamental character. Those moons add detail. They add richness, but they do not change the identity of the planet they orbit. Charon changes the identity of Pluto. It turns Pluto from a singular object into half of a system. It converts a lone dwarf planet into a paired world. It replaces a simple gravitational hierarchy, one body dominant and one subordinate, with something mutual, reciprocal, and dynamically unresolved. The moment you properly account for Charon, Pluto stops being a world you can point to and say, "That is one thing." It becomes a world you can only describe accurately by saying, "That is one of two things that cannot be fully separated." The public debate about Pluto has always focused on the wrong question. Since 2006, the argument has been about whether Pluto deserves to be called a planet. Supporters argue that it orbits the Sun, it is round, it has moons, and it should never have been demoted. Critics argue that it has not cleared its orbital neighbourhood and therefore fails the International Astronomical Union's definition. Both sides treat Pluto as a solo actor. Both sides argue about the label that should be applied to one object. Neither side grapples with the deeper strangeness that makes the labelling question feel almost trivial by comparison. Whether you call Pluto a planet, a dwarf planet, or something else, you are still talking about it as if it were a single entity. You are still imagining one world floating alone in the darkness, waiting for the right category to be pinned on it. But Pluto does not float alone. It has not floated alone for 4.5 billion years. The real shock about Pluto is not that it was demoted from planet to dwarf planet. The real shock is that Pluto was never one world to begin with. The whole debate about its classification assumes an object whose identity is self-contained. An object you can point to and say, "This is Pluto. What shall we call it?" But the Pluto you are pointing to is only half the story. The other half is orbiting right next to it, locked to its face, sharing its centre of mass, governing its spin, organising its satellite system. Pluto without Charon is a fundamentally different object than Pluto with Charon. And the Pluto that exists, the one that is real, the one that has been real for billions of years, is the Pluto with Charon, the paired one, the entangled one, the one that cannot be described alone. From the moment Charon was captured, Pluto became something the solar system had never seen before in such extreme proportions. A body whose rotation is set by its companion, a body whose gravitational centre exists outside its own surface, a body whose satellite system orbits a point in empty space rather than the body itself, a body so deeply entangled with its largest moon that the two share a single gravitational identity. Pluto is not a planet, but it is not simply a dwarf planet either. It is one half of the solar system's most extreme paired world, a system that operates by rules no other planetary body follows, that demands vocabulary the field has not yet invented, that sits in a categorical gap between planet-moon and binary that no one has formally closed. The Pluto-Charon system challenges us to think about the solar system differently. We grew up with a model of clean hierarchies, stars at the centre, planets around them, moons around the planets. Each level of the hierarchy is neat, orderly, clearly separated. But nature does not always comply with hierarchies. Binary stars are common. Triple star systems exist. Planets orbit two stars at once in circumbinary configurations. The universe is full of systems that refuse to organize themselves into the clean tiers we prefer. Pluto and Charon are simply the solar system's most dramatic example of this refusal. They sit at the boundary between two categories and decline to choose either one. They are a reminder that the map is not the territory, and that the territory sometimes contains features the map makers never anticipated. And perhaps that gap should stay open. Perhaps the Pluto-Charon system does not need a label that resolves its ambiguity. Perhaps the most honest thing we can say about it is that it is genuinely strange, stranger than any single classification can capture, stranger than the word planet accommodates, stranger than the word moon describes, stranger than the phrase double planet quite reaches. The system resists our categories because our categories were built from examples that do not include anything like this. We invented the word moon by looking at Earth's companion and generalizing outward. We invented the word planet by looking at the bright wanderers in the ancient night sky and drawing boundaries around them. Neither word was designed to describe what happens when two icy worlds at the edge of the solar system lock together so completely that separating them into primary and secondary feels like a lie. Pluto and Charon are 4.8 billion kilometers away. They orbit the Sun once every 248 Earth years, tracing a path so slow and so elongated that a single Plutonian year spans the rise and fall of entire civilizations. From that immense distance, in the cold, dim light of a sun that appears more like a bright star than a burning disk, two worlds circle an invisible point in space. They show each other the same face, forever. They spin at the same rate. They orbit the same center. Their four tiny companion moons tumble chaotically through a gravitational field that neither world alone could produce. The system is small, cold, distant, and utterly unlike anything else we have ever found orbiting our sun. When Clyde Tombaugh discovered Pluto in 1930, he found a dot of light moving slowly against the background stars. For 48 years, that dot was assumed to be one object. Then James Christie noticed the elongation in a photographic plate and revealed that the dot was two. But even then, the assumption held that one was the main body and the other was its satellite. It took decades of measurement, a lucky alignment of mutual eclipses, a space telescope, and a spacecraft that travelled for 9.5 years across 3 billion miles of empty space to reveal the full truth. And the truth was not what anyone expected. The truth was not a small planet with an interesting moon. The truth was a paired world, a gravitational system, a relationship so deep that calling one body the primary and the other the secondary misrepresents every important fact about how they interact. Pluto is not a world with a moon. Pluto is one of the solar system's strangest paired objects. A body whose identity is inseparable from the companion that shares its gravitational center, a world that makes sense only as half of something larger than itself. The real strangeness of Pluto is not that it was demoted. It is not that it is small. It is not that it is far away or cold or covered in frozen nitrogen. The real strangeness is that it was never singular. From the moment of its violent origin, from the ancient collision that placed Charon into orbit, Pluto has been one half of a pair that the solar system had no name for. Charon did not merely orbit Pluto, it redefined what Pluto is. And what Pluto is, when you finally look closely enough to see the full picture, is something we still do not have the right word for. A world that is not one world. A system that is not quite a binary. A pair that is not quite a planet and its moon. Something in between. Something unnamed. Something stranger than a planet. Sitting at the edge of the solar system, facing its partner across 19,000 kilometers of silence, locked in a gravitational embrace that has lasted longer than complex life has existed on Earth, and will continue long after the last human question about what to call it has been forgotten.